Fraction decomposition round 2. So now we're going to do problems. We're doing the same exact thing, except now there will be repeating factors. What does that mean? Well, if I factor this, see how instead of distinct factors, I get the same factor twice? I could write that as x plus 2 squared. That is a repeating factor. So the big thing here, you're going to see this is a really simple problem. It's all how you set it up. So to set this up, the first fraction gets one of those, and the second fraction gets both of those. And to make that less something that you memorize and more something you understand, let me show you a number fraction where this plays out. Suppose you have 3/4. That is equal to 1/2 plus 1/4, right? Because this will be 2/4 plus 1/4 is 3/4. Now, look at that. That's 3 over 2 squared equals 1 over one of those 2's plus 1 over both of those 2's. So that is how these can play out. And that's why we got to set them up like this. So when I have recurring or repeating factors, I have to do a fraction for one of them, two of them. If there's more than two, then I'd have to have one for the cubed version. We'll get to that down here. But so far, here's the setup. If you can get the setup, this is a piece of cake. I don't know what the numerators are. We'll call them A and B. Now I forget about that side of the equation, and I just actually get common denominators and add these up. So this is good to go. All I need is an x plus 2 here. I don't like that marker. So this would give me 5 equals ax plus 2a plus b, and that's it. So I have x terms and constant terms. Ax is 0. Oh, this is going to play out too simply. Let me make this x plus 5. I don't want this to totally collapse like that. So we have, all right, so now we'll have something there to set it equal to. And this is 2a plus b has to equal 5. 2a plus b equals 5. Well, if a is 1, then b is 3. So my answer, this fraction, is the same as 1 over x plus 2 plus 3 over x plus 2 squared. Right? This equals that. I unadded the fraction. Like I said, the math was really easy in this one. It's all focusing on the setup. Let's try that next one. That's going to be a little more interesting. Plus, I've thrown a new kind of kink into it that we haven't addressed yet. So the setup for this is, I'll start with this one. Doesn't really matter. I could have one of those x minus 3's, or I could have both of those x minus 3's. And I don't know what the numerators are. Now I forget about the left. How would I actually add these up? Well, this one I'd have to times by both of those, which I'm going to multiply that out because it's convenient. This one I have to multiply by that and one of those. So that's going to be minus 2x minus 3. And this one only needs the x plus 1. So now my common denominators are in place, and I really can shift my focus to the numerator, which would be x minus 5 has to be the same as, that's a little sloppy, so let's make sure I do that. Okay, let me give it a quick once over. Yep. All right, I think we're all right here. So now I have to break this down into my x squared, linear x, and constant equations. So here we go. Squareds. A plus b equals nothing. Linears minus, this should be 6xa, sorry about that, plus 9a. So minus 6a minus 2b plus c equals 1. And we have 9a minus 3b plus c equals minus 5. So for this problem, I would grab these two right here, multiply this one by minus 1 so the c's drop out, and let's call that step 1. So if I multiply this by minus 1, I'd have 6a plus 2b minus c equals minus 1. And this I'm just going to carry over. And then I'm going to add them column-wise. So here is an equation that came from these two. I haven't used this one yet. Notice they all have the same variables. So for step 2, I'm going to steal this result and combine it with the one I haven't used yet. And nicely, those drop out as is. And the new kink in the problem is we're getting a fraction answer. We haven't done that yet. All right, so I can use any equation on the board to try to get the other b and c. I think we definitely are drawn here. If a is minus 3/8, then b must be plus 3/8. I'm not even going to show my work there. I think that's pretty clear. But I do have to figure out c, and I want to be clear about that, so I'm going to do some erasing here. So here's my a and b, and I'm going to be plugging those in here and here. So let's see what that looks like. So I would have 9 times minus 3/8 minus 3 times positive 3/8 plus c equals minus 5. So I'm going to erase those two now that we have this. Let me just record the fact that a was minus 3/8, b was plus 3/8, and we're on our way to solving for c. All right, so here we go. Minus 27/8 minus 9/8 is minus 36/8. We could simplify, but I'm just going to multiply by 8. So 8c is minus 4, so c is minus 1/2. Okay. So now I'm going to spend a little extra time talking to you about format. I could write this. So see my original breakdown? There's my answers. I could write this. That is true, but it is super bad form. Let's just focus on this fraction right here to show you like what we're really going to do. So if I see this, I know that that's actually like this. And look at what I end up with. Let me give you another way to deal with it. See this right here? A over x plus 1. That is the same as a times 1 over x plus 1, right? So that would be the same as minus 3/8 times 1 over x plus 1. The point is, however you think about it, the better way to do this is to not even write this down. It is true, but that is really bad form. It's much better if you're fluent with the fractions. So see this? See this? The minus goes in front of the fraction, the numerator stays in the numerator, and the denominator is going to be down here. Why? Because that's why. Plus, b is 3/8. The 3 is going to stay in the numerator, and the 8 is going to go down in the denominator. Plus, except c is a minus, so it's going to turn this minus. 1 stays in the numerator, and the 2 goes in the denominator. Now we could distribute down here and clean this up, but I am satisfied with this answer, right? So I just want to see that you can break it down, you can get the solutions, and you're fluent enough with the fractions that you can put it in a good format. All right, one more to go. Right there. A lot of people mess up on this one. See, this factors into x cubed times x minus 2. And when you see that, right, people see that that repeats, but a lot of times they miss that that repeats. This is x times itself 3 times. So be careful about that. So this is going to be, I'll take this one first. That's going to be in the mix. I'm going to have a fraction that has one of those 3, a fraction that has 2 of those 3, and a fraction that has all 3 of those 3. And that would be analogous to this problem right here. Right? This is 3 2's. That's 1, 2, and 3. And that works. So that's what's happening here with the x's. Same thing as if they were numbers. I have no idea what the numerators are. A, B, C, D. Nobody likes to see a lot of letters up there, but it is what it is. You're going to see that this works out pretty nicely. So, we got to get our common denominators. Well, what's that going to look like? This only needs an x minus 2. This needs x minus 2 and one more x. This needs x minus 2 and 2 more x's. And this just needs the x cubed. All right, so now we've got to just plow through the algebra. This numerator has to be equivalent to bx cubed minus 2 bx squared plus cx squared minus 2cx plus dx minus 2d. Okay, do a quick double check, make sure you didn't miss anything. I think it's looking good. Now we're going to break this up into our system. We have cubes, squares, linears, constants. A plus B is nothing. A plus B is nothing. Minus 2B plus C equals nothing. Minus 2C plus D equals 6. And finally, minus 2D equals minus 4. All right, well, there's a lot of things to figure out there, but this actually is not looking too bad. Let's start with the easy one down here. Step 1, D must be 2, right? Step 2, now that I know D is 2, I'm going to put that right here. And I get C. Now that I know C, I'll feed it back here. in our final step, if b is -1, then a must be +1. So there we go. We know what a is, b, c, and d. So this one is all integers. I could have got some fractions in there, but I didn't in this case. I need some space, so I'm going to clear out all this work. And now all I have to do is state my answer. This fraction decomposes into 1 over x minus 2, minus 1 over x, minus 2 over x squared, plus 2 over x cubed. And if we were so inclined, we could actually do that addition and subtraction and end up with that answer and prove it, but we will call it good. All right, next step is for you to practice some of these, and we got 2 more sections left to go.